In this video, we're going to look at an exam question looking at forces acting on an object in equilibrium. If you look at the question, it says that this particle is in equilibrium. Well, if the particle is in equilibrium, that means the sort of net force acting in each direction is equal to 0. So that means that if we look in any direction, it's 0. So if we look at horizontal forces, so that's the net horizontal forces, so the total. Net horizontal forces equals 0 and net vertical forces equals 0. That's what equilibrium means. Unfortunately, if we look at our diagram, we have some forces. We have this mg, which is acting in the vertical direction, but we have our 60 Newton force, which is acting at an angle, and our 50 Newton force, which is also acting at an angle. So what's vital to this question is knowing that we can break down any force into two components. So if we have a force F here acting at an angle, let's say alpha, to the horizontal, that gives us a right angled triangle, and we can break this force down into a horizontal component and a vertical component. And this all comes from trigonometry. I'm not going to go through the actual derivation of this, but the point is that the force, the vertical component in this case is F sine alpha, and the horizontal component is F cos alpha. So the component that's opposite the alpha gives F sine alpha, the component that's adjacent to the alpha gives F cos alpha. So that's what we're going to do. So looking at our actual question, we can break this 60 Newton force down into a vertical force acting upwards, which is 60 sine 48, and a horizontal force which is acting to the right, which is 60 cos 48. And we'll do the same with our 50 Newton force. So that can be broken down into a vertical force of 50 sine alpha and a horizontal force now of 50 cos theta. Sorry, I said alpha before, that should obviously be theta. Notice that the 50 cos theta is acting to the left, whereas the 60 cos 48 is acting to the right, just from looking at the directions of our initial 60 Newton and 50 Newton forces. Okay, so we've broken down our forces into horizontal and vertical components, and that means that actually the whole question will be relatively straightforward. So let's look at part A in full. It says resolving horizontally. So resolving horizontally means we just need to look at our horizontal forces. We don't need to consider any of the vertical components. We need to choose a positive direction. So horizontally means either the left or the right. Let's choose to the right as being our positive direction. So forces to the right will be positive and forces to the left will be negative. So what forces do we have acting? We have a 60 cos 48, which is to the right, so that's a positive. We have a 50 cos theta, which is to the left, so it's negative. And actually they're the only two forces that are acting in the horizontal direction. Every other force that we can see on the diagram is acting in the vertical direction, because we've broken down our forces into just horizontal and vertical components. So our total horizontal force is this, and because the object is in equilibrium, this is equal to 0. So now we just have to solve this equation. We get cos theta equals 60 cos 48 over 50, just rearranging, and if you work that out, you get cos theta is 0.80296, I think. And then so theta is, we take the inverse cos of 0.80296, and we get 36.587 degrees, which is 36.6 degrees to 3SF. Okay, so we've done part A, we've worked out what theta is. Now to find m in part B, Now we're going to look at the vertical forces. Again, we have to choose a positive direction in our exact. We'll choose up to be the positive direction. So then, what forces do we have in the vertical direction? We have a 50 sine theta. Well, we know what theta is. It's now 36.6. And that's up, so it's positive. We have 60 sine 48, also acting up, so that's positive. And we have mg acting downwards, so that's a negative mg. And again, the net vertical forces are 0 because it's in equilibrium, so this thing is equal to 0. So again, we're now just going to rearrange this and work out what mg is. If we plug in 50 sine 36.6 plus 60 sine 48 into our calculator, we get that mg is equal to 74.390. The question asks for m, so m is just 74.390 divided by g, which is 9.81, and we get m being 7.58 kilograms. Again, to